Hi students, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to you. And everyone, yes students, am I clearly visible and audible to all of you or not? So today we are going to do units, conversions and physical constants that are used in physical chemistry, right? Firstly, let me know in the chat box if I am clearly visible and audible, because today's class is very important for all the students out there who are preparing for their NEET exam. And especially what I have seen in physical chemistry, what is the biggest problem that students face is calculations, and the next part is unit conversions, right? For example, let me just give you an example that why this lecture is so important for all the students out there, right? So if you see this here, can you see this is NEET 2024, NEET 22 question, right? Can you see, just go through this. Now the answer, they have the amount of this required to prepare this. Now the answer that you have to give in a certain unit, right? Can you see this here? Bohr radius, they are asking in picometer angstrom, right? Again, that means you should know picometer, angstrom, all those conversions you should know. Then if you talk about NEET 2021 question, here again, the conversion centimeter, meter, this is in kilohertz, right? Now all these things are required. Then if you talk about the next one, NEET 2024, again this is in calories. Now here, what if this was not given to you? Now R, what is the value of R in calories? What if we want to get the answer in calories? So all these things plays a very important role, and that's why this lecture is for if you're in class 11th, if you're in class 12th, or you are right now in you are a dropper, right? You are class 13th, you are a dropper, right? All these things are very important for you. That is unit conversions and physical constants. Okay, so I'm going to start this. Everybody do let me know if I am visible and audible to you, so that we can start with the session. One important thing, students, here is another example here. As you can see, here also, they have given 1 liter atmospheric to joule conversion they have given. Now, the answer you have to get in joules, right? What if this was not given to you? Mostly in NEET 2026, these conversion, the hints will not be given to you in the exam. You have to know this, right? If you know this, only then you'll be able to solve the answer, right? Okay. Now, a very important thing for all the students who are present here, that guys, we are conducting a validation ceremony, that you can see VAL Celebrations 2025. Now, ma'am, what is this? Right, this is for the excellent results of Vedantu that we have given, whether you talk about JEE Mains, JEE Advanced, NEET and other categories as well, the Olympiads as well, the amazing and awesome results that Vedantu has given. And we are celebrating this along with the students right down in our Bengaluru center, right? We are celebrating it, right? Everything that is mentioned in detail. And ma'am, but how can we watch that, right? So don't worry, it is coming soon on 21st 6 2025. That means just 2 days after you will get this on YouTube on live. You will get that ceremony here, and you will see the motivation that you will get after seeing the students, right, who have actually right now achieved their dreams, right? Because those students are the people who were just like you, who had dreams in their mind, who wanted to, be like AIR 3, 4, 5, 1, all these things, right? Now they have achieved their target. They have, someday they must have just randomly thought about it. Now they are living their dream life, right? Now what you will feel after seeing them is that I want to be there, right? So you will see the uh, hard work, how it works out, and how you achieve your dreams, how you're living the life that you always wanted, right? That will also motivate you to see those shining stars right? So I would definitely advise you. And it is going to be live on 21st, 6th and 2026. That means just 2 days after that will be live. Okay. So now let us start this session, students. Now the topics to be covered are, if you talk about the topics that we are going to cover here are, right? First is unit conversion, then temperature unit, then pressure unit, volume unit, gas constant, energy, all these units we'll talk about. Then in the last, we will talk about some physical constants, right? So this is our topic for today. So I'm going to start with the unit conversions here, right? So for unit conversion, you need to know two things. One is basic unit, other is derived unit. So what are the basic units? Basic units are, that is, you can say, are not derived from anything. They are forming the building blocks of unit, like you have grams, you have meter, you have seconds, right? So now from this gram, meter and second, these are the fundamental units. But if you talk about the derived units, let's talk about velocity. It is meter per second. It is formed from meter and second, right? So let's talk about density. Density is equals to mass by volume. Now, ma'am, volume is a density unit or not? That I'll talk about. Volume is a derived unit or not? That we will talk about. Why? Because volume is length into breadth into height. In reality, volume is meter cube, or you can say centimeter cube. That is a derived unit. So if you talk about density, let's say density is in gram and volume is in, let's say, centimeter cube. So again, it is a derived unit, right? So volume is also a derived unit. You talk about acceleration, it is meter per second square. It is also derived unit. So derived units are that are formed from the basic units by variating them, right? These are called the derived units, right? Okay. So now let us talk about some fundamental units, right? I have given you example of gram, seconds and meter. There are other also. So let's talk about that. For length, we take meter. For mass, we take gram, kilogram, but kilogram, meter and second, right? That is the SI unit, right? There is two system. One is called SI unit, one is called CGS system, right? In CGS system, you take meter as centimeter, this as gram, this is also as second. So that's why it is called CGS. But this is SI, right? So it is SI unit, that is meter, this is kilogram, this is second. That is very important, right? Now, for current, we use ampere. For thermodynamic temperature, we use Kelvin. Now, what is the SI unit of temperature? That is Kelvin. That is not degree Celsius. That is Kelvin. Okay. Now, amount of substance, we measure it by mole. That we will study in some basic concepts of chemistry. The chapter number 1 of class 11th. Luminous intensity is measured by a candela. Right. Now, in chemistry, what are the useful units for you? In chemistry, students will use meter, kilograms, seconds also, ampere also will use, temperature also we will use. So these are the most used. Mole, so we will have a different chapter only on moles, right? And candela, you will not use this, right, in chemistry, but still it is written here. So that's why I'm telling you this, right? Okay, so this you have to know, right? Now, let's talk about the derived units. So as I told you, derived units are derived from the basic unit, like you have acceleration, velocity, you have density, all these are derived from the basic units that you have, the fundamental units that you have, right? Now students, let us see this. This is very important thing that I'm going to teach you now, because this is like almost through entire physical chemistry, this is used, right? That is, you might have seen picometer, nanometer, micrometer, milli, centi. These are the most used units, right? If you talk about here, deca is most used, deci is also used, kilo is used, mega is used. Then these are maximum used, right? So I have circled all of them. They are maximum used. Otherwise, you should know all of them. Now, I'll give you one simple thing here. That is, whenever you are doing conversion, okay, so I know that conversions are quite difficult for students. You should know one thing, right? Students, understand this thing. Whenever we are doing conversion, converting meter to centimeter, meter to femtometer, meter to millimeter, All these conversion, nanometer to millimeter, all these conversion is what we need to learn, right? For that, you should understand one rule here, right? That is, first thing is, if you're converting something smaller to something bigger, right? You're moving to something smaller to something bigger, smaller to bigger, smaller to bigger. What you will do? You will divide it, right? When you will move from smaller to bigger, small to big, or you can say small to large, small to large, what you will do? Small to large, and one will be large to small. One will be large to small. This also I'll tell you what is small to large, large to small. Trust me, if you do this way, things will get very, very easy for you. Otherwise, you will get, get irritated in between that what is happening here, right? I know that you are NEET aspirants, right? I know that you find these things difficult. That's why this is for you, right? Small to large, SL, small to large, you will always divide it, right? Always divide it. Large to small, always multiply it. Okay? SLD. Just remember SLD. What you have to remember is SLD. What is the trick, students? Everybody write it down in the chat box. SLD. Just remember this thing, that whenever you have small to large, always that will be divided, right? Everybody write it down in the chat box. SLD, 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 SLD. Spam it in the chat box. That should be clear in your head whenever you're doing small to large, right? After this, I'll explain that what exactly is this small to large, right? Now, if you talk about small to large, this is the first thing. What exactly is this? First, we will talk about dots. This is the first dot. Now, I'm going to teach you the second dot. Then we will connect all those dots here, right? So, first dot is to understand that whenever it's a small to large, we will always divide it, SLD, right? Now, let's talk about this thing. Just remember one thing, what are the smaller values? I am taking a base value. Base value is nothing like meter, right? Now we know that millimeter, right? Millimeter is smaller, but megameter, or you can say kilometer, is larger. This is small to large. This is small to, this is large to small, right? Let's talk about nanometer. Nanometer is smaller as compared to meter. See, if someone is asking you to convert meter to nanometer, you are doing large to small, right? But when you are converting meter to kilometer, you are converting small to large. Okay, this is some like you familiar examples that I am talking about, right? Now, ma'am, next is what we have to understand, that base is simple meter or simple gram. That is the base. Meter, gram, these are the base, which do not have any milli, centi, mega, deci attached to it, right? You have to see that from that base, which one of the following are smaller. Centi is smaller, milli smaller, micro, nano, pico, femto, atto, zepto, yocto. All these are the smaller units, right? Now, centi means 2. You don't have to remember -2. Nobody is asking you to remember -2, -3. Don't remember that, right? Just remember centi is 2, right? Milli is 3. Centi is 2, milli is 3, micro is 6, nano is 9, pico is 12, femto is 15, atto is 18. Now you just have to add 3 into it, okay? 9 plus 3, 12, 12 plus 3, 15, 15 plus 3, 16, 17, 18, 18 plus 3, 21, 21 plus 3, 24. What we added? 3, we added there, right? Centi, milli, after that just add 3. Milli, micro, nano, pico, femto, atto, zepto, yetto, right? But what is most asked is pico, nano, micro, milli, centi. These are the most asked conversions in your exams, right? Okay, we have just added 3 into it, right? Now these are smaller, right? These are bigger. Now this you have to understand, this deci is also smaller, right? That is 1. Deci is 1. After that you have bigger. Deci is smaller 1. Deca is bigger 1. Okay? Deca will be more than meter. If you talk about meter, if I am converting into decimeter or I am converting into decameter. So decameter is bigger, decimeter is smaller. Okay, this is decimeter is smaller and this is decameter which is bigger. Right? Till now I am just explaining which one is smaller, which one is bigger. Right? Deca is also one. Hecto, very rarely asked. This also I'll tell you what is mostly asked. Kilo is asked 3. Mega 6. Giga 9. Then you just have to add 3 into it. Okay. So hecto is 2. Same game. 1, 2, 3, 6, 9. Then you have 12, 15, 18, 21, 24. Same thing. You just have to remember that when it is yocto, it is smaller. When it is iota, it is bigger. When it is zepto, it is smaller. When it is zeta, it is bigger. Right? When it is the atto, it is smaller. When it is exa, it is bigger. This is peta, which is bigger, and femto is smaller. This all you have to remember. Right? And out of this also, let me tell you what are important. Out of this also, mega is important, kilo is important, deca, deci, and then giga. All these are important. Rest are very, very rarely asked, but you should at least have an idea about it. Right? Okay, students. Now, we are going to do the conversions. Okay? Conversions. Now, tell me, is that thing clear to everybody? That first thing is SLD, smaller to bigger, always divide. Right? Smaller to larger, always divide. Larger to smaller, you always multiply. Now, larger and smaller also, I have explained you what is larger, what is smaller. Now, we will do the conversions so that we are able to understand what exactly we are talking about. Right? Okay. So, I'm going to do this conversion one by one. So, first conversion, as you can see, is from 2 megagram to dash gram. Now, students, tell me one thing. Mega is bigger, larger or smaller? Mega, this is gram, and this is megagram, right? Now, they are asking you to convert megagram to gram. So, you can write megagram to smaller, that is gram. Larger to smaller, do we need to multiply or divide? Larger to smaller, do we need to multiply or divide? And mega is 6. Okay, mega is 6. I just remember 6. I don't remember anything. Mega is 6. That I remember, right? Mega is 6. So it means 10 raised to power 6 either will be multiplied or it will be divided, right? Now that I have to think whether it will be multiplied or divided. Larger to smaller is multiplied. So that will become 2 into 10 raised to power 6 gram. That is going to be your answer here, right? Okay. Next is going to be 20 centimeter. 20 centimeter is equals to dash millimeter. Right? Now let's understand this thing. 20 centimeter. Now always and always when you are given with some centis converted to milli, don't do it directly. Go through always. Now I always ask students, when you have to ask some permission, you don't ask your father directly. You always ask your mummy and then you ask your father. Right? Ask her to ask your father. Right? Isn't it what you do? Same thing we will do here. Meter is our mummy. Right? We'll always firstly convert it to meter or grams. Then it will be converted further. So firstly what we will do, centimeter is smaller. It is converted to meter. Then meter is again converted to a smaller, that is millimeter. Okay. Now see this here. Centimeter to meter, smaller to larger, it will be divided by what? 10 raised to power centimeter. Centi means 2, right? So it will be divided by 2. Divided by 2 means it will be 10 raised to power minus 2. So that you can see 20, this will become 10 raised to power 2 and this is milli, so it will become 10 raised to power 3. Okay? So firstly what will happen, 20 centimeter is divided with 10 raised to power 2 and this is getting converted to, you can say this will be into 10 raised to power minus 2 meter. Then meter is again converted to millimeter. Now larger to smaller, It will be multiplied. Now it is multiplied by 20 to 10 raised to power minus 2 multiplied by 10 raised to power 3. This will become 1 only. So it will become 20 into 10. So that will become 200 millimeters. That is going to be the answer here. Okay, answer is going to be 200 millimeters. So always you have to go through this format. Now, if you want to make it even easy for you, what you can do here, this is divided, this is multiplied. So this will become 10 raised to power minus 2, this will become 10 raised to power 3. So this together will become 10 raised to power 1. Now just multiply it with 10 raised to power 1, that will be your answer. Okay, got it? Overall result here also you can see. Right? Third one is 1 meter to centimeter. This is very simple. 1 meter to dash centimeter. This so directly you can say, but if you follow this way, then this is meter, centimeter is smaller. Larger to smaller is always multiplied. L, S is always M. Okay, so it is larger to smaller is always multiplied. So it will be 1 into 10 raised to power 2, that is 100 centimeter. Okay, right everybody? This was our conversion. Now let's talk about the next conversion here that you can see. Convert the following. Okay, one by one we have to do this. Right, this also what I'll do, I'll just copy paste this thing, that will be better for you. Now let us see who is going to answer this to me. Right, let us see who is going to answer this to me, because again this becomes very, very important for you. Okay, you have to do this yourself as well. Now this is the first one that I am picking is 10 raised to power 3 nanometer to femtometer. Right. Now students, see one thing here. This is nanometer. This will be firstly converted to meter, then it will be converted to femtometer. Now ma'am, what was femtometer? That you can see over here. Femtometer right here. Right, that was smaller, that had 15. Right, okay. Nanometer had 9. You can see this here. Right, so I am just going to pick this 15 and 9 here, and then I'll get my answer. So let us see that. Same way we are going to do this. Right, this is 10 raised to power 3 nanometer. Now nano means 10 raised to power 9. Smaller to larger is always multiplied, smaller to larger is divided. So this will be 10 raised to power 3 divided by 10 raised to power 9. This is meter. So it will become 10 raised to power minus 6 meter. Or you can just remember this thing. This will be divided by 10 raised to power 9. Then after this, it is again 10 raised to power, this is 15. This is 10 raised to power 9. Now you have larger to smaller. Larger to smaller is multiplied. So this is 10 raised to power 3. This is 10 raised to power 9. This is multiplied by 10 raised to power 15. Right? You get this answer. This will be 5, 6, 6, 9. So it will be 10 raised to power 9 femtometer. So answer is going to be 10 raised to power 9. Okay? Right? Ma'am, isn't milli 10 raised to power 3? This is what I have eliminated from your life. Right? Beta, that's why I have made this thing for you. SLD. Just remember SLD. Don't remember minus 3 plus 3 minus 2 plus 2, because in that chances of doing mistakes are maximum, especially for NEET aspirants. Right? They do mistake unless and until you are very sure that you know where you have plus, where you have minus, when you have to multiply, when you have to divide. If you are clear on that, go for that method. Otherwise, just remember SLD, smaller to larger will be divided. Now, I am not asking you to remember that femto is 10 raised to power minus 15 or 10 raised to power plus 15. Just remember femto is 15. That's it. Right? Nano is 10 raised to power 9. Now, whether it will be multiplied or divided, that you have to see from the conversion. Okay? This is what I told you. Okay? Okay? Now, this last two conversions we are doing, okay? Otherwise, we are going to jump to the next topic then. So, if you have still any problem, then let me know. This is 40, this is gigagram, this is to dash gram. Now, giga is bigger or smaller than gram? It is bigger. So, gigagram is converted to a smaller part, that is gram. Giga is what, beta? Giga is 10 raised to power, you can see this here students. Giga is 10 raised to power 9, right? So what we will do, here we will do the conversion. I am not going to write minus 9 plus 9, just remember this. Larger to smaller is always multiplied, right? So you'll always multiply this with this 40 into 10 raised to power 9 and you will have your answer here, right? Next one is 0.002 nanometer equals to how much picometer. This is the common conversion that you will see in your numericals, right? Okay. Now let us see that, everybody. Let us see that. This is nothing but this is 2 into 10 raised to power minus 3 nanometer because you have 3 zeros here, right? So that will be 10 raised to power minus 3, right? Now, if you see this, nanometer, firstly we will convert it to meter, which is bigger, right? Larger value. Then we will convert it into again picometer. Now see what I am going to do. Nanometer to meter. Nano is what? Everybody write it down in the chat box. Nano is 9, 10, 11, 12, 13, 14, 15, 16. Which number is for nano? Which number you have for nano? Everybody in the chat box. Which number you have for nano? Very good, very good, very good, very good. Sweetie, Siddharth, Sanjay, Sadiki, Punya, Lafita, Paki, Shah, Vatsalya. Very good. 9. Very good. So number is 9, right? And what about pico? What is the number for pico? Beta, please don't do minus 9, 3. If you remember minus 9, then don't go through this method. Okay, then you don't have to learn this method, right? If you're remembering, don't mix two methods, okay? If you're learning minus 9, then don't do this method. If you're learning simple 9, then you have to do this method, okay? So please don't do this mistake. I don't want to, mess up with the already learned concept, right? Okay, yes. Pico is simply 12. So that means this is 10 raised to power 9, this is 10 raised to power 12. So rather I will write it as 10 raised to power 9, this is 10 raised to power 12. So I'll write it as 10 raised to power 9, this is 10 raised to power 12. Now, you have to tell me whenever we convert from smaller to larger value, we multiply. This will be multiplied. When we always convert from larger to smaller, this will be divided. Okay. So if I multiply and divide this, multiplied by 10 raised to power, so simply can I just write it like this? 2 into 10 raised to power minus 3 is multiplied by 10 raised to power 9 divided by 10 raised to power 12. That is going to be your answer when it is converted to picometer. So answer will be, this will be 10 raised to power minus 3 only. So answer 2 into 10 raised to power minus 6 picometer is your correct answer here. Right, everybody? Clear? Is this thing clear to everyone? Because I am not going to take up this lecture again and again, right? Throughout the next year, this is the only lecture I am taking for unit and conversions, right? Because after this class, I am just going to teach you that, okay, this is the answer. You can easily solve this because I have already told you about the conversions. Okay, right? If you have any doubt, you can ask me now only. Because after this, we are going to start with the temperature conversion, right? We are going to start with the temperature conversion. So temperature has 3 units, right? One is degree Celsius, then you have Fahrenheit, then you have Kelvin. Kelvin is the SI unit, and in most of the temperature in Kelvin, you will see in most of the numericals of electrochemistry, chemical kinetics, you will see it in solution chapter, you will see this in equilibrium also, you will see this in thermodynamics as well, right? Almost all the physical chemistry formulas have temperature, right? And that temperature will be in Kelvin. That is the SI unit. But what you have to remember is how to convert. Now, which is the most important conversion that you have is from degree Celsius to Fahrenheit. So now this is very important for you to understand. If you see this here, water boils. In Kelvin, we say 373 Kelvin. Here we say 100 degrees Celsius, right? And here we say 212 degree Fahrenheit. right? If you talk about water freezing point, freezes at 0 degrees Celsius, that we talk about 273 Kelvin, and in Fahrenheit it is 32 degree Fahrenheit, right? Now, absolute zero is 0 Kelvin, right? In degree Celsius, it is minus 273 degrees Celsius, and in Fahrenheit, it is minus 459 degree Fahrenheit. Ma'am, do I have to remember all of them? No, I am just giving you the comparison. It's not like I am changing the temperature. I am just saying that what is 100 degrees, same is 373 Kelvin, same is 212 degree Fahrenheit, right? Now, Fahrenheit, very, very rarely you will see. See, if they want to make like NEET 2026 really disastrous, right, really difficult, then they will give you some temperature in Fahrenheit. But I don't want to take any risks, so that's why I'll give you the formula Fahrenheit conversion also, right? Till now, they give you only in degrees Celsius to Kelvin. These are the conversions they give till now, right? But we can't take risks. We are also going to talk about Fahrenheit, right? So first thing is, what is the conversion of Kelvin and degree Celsius, right? Kelvin and degree Celsius, we can say that 0 degrees Celsius is equals to 273.15 Kelvin. So when you have to convert anything into Kelvin from degree Celsius to Kelvin, just add this point, right? Okay. Whenever you want to convert anything into Kelvin from degree Celsius to Kelvin, just add 273.15 and that will be converted to Kelvin, right? Okay. Let's see this here. Let's see this here. If you talk about degree Celsius and degree Fahrenheit, what is the formula for that? Then guys, this is the formula. Let me just make it very clear, right? This is degree Celsius. Wait a minute. This is degree Celsius. Okay. And this is Fahrenheit. Okay. Now, if you can see here, this is degree Celsius is equals to 5 by 9 Fahrenheit minus 32. Okay. Degree Celsius equals to 5 by 9 degree Fahrenheit minus 32. That you should remember. Okay. That is the conversion unit of degree Celsius and degree Fahrenheit. Right. Now, let us talk about this thing here. Let us do these conversions. Right. I think by these simple conversions only, you will get to know so many things. Right. So, first conversion I'll do here. Right, wait a minute. Chal, I'll do this like this. Okay, chal. Now let's start this. The first conversion I'm going to do degree Celsius to Kelvin. Degree Celsius to Kelvin, all you have to add is plus 273.15. So I'll just add 100 plus 273.15 Kelvin. So answer will be 373.15 Kelvin. That is your correct answer of first, right? That we have done. Second is they are asking about degree Celsius to degree Fahrenheit. Second is there we are doing the conversion of degree Celsius to degree Fahrenheit. Okay. Degree Celsius to degree Fahrenheit, that is 40 degrees Celsius to 40 degree Fahrenheit we are talking about, right? Okay. So this is 40 is equals to degree Celsius is 40, 5 by 9. This is Fahrenheit minus 32, right? Just put the values in the formula, nothing else you have to do. This is 9 into 40, this is 5, right? Then this is Fahrenheit minus 32. Now, bacha, tell me what is the value in Fahrenheit. Everyone, let me know what is the value in Fahrenheit. Students, what is the value in Fahrenheit? Shabash. All you have to do, most of the part I have already done. Let me know. Very good, very good. 104, let us see. Right? Fahrenheit will be 72 plus 32. So it will be, yes, 4, 7, 8, 9, 7, 8, 9, 10, 104 degree Fahrenheit. That is going to be the answer for degree Fahrenheit. Okay, all you have to do is put in the values and you will get your answer. Now the third one is Kelvin to degree Celsius, right? Kelvin to degree. That means first, not degree Celsius, Kelvin to degree Fahrenheit. Okay. So let's talk about the third one. That is, first you will convert 50 Kelvin to degree Celsius, then to degree Fahrenheit. Okay. So 50 Kelvin is equals to how much degree Celsius? So 50 Kelvin is equals to 273.15. You can see in degree Celsius it will be. Because see, when you have to convert degree Celsius to Kelvin, you have to add. See, when you have to convert Kelvin to degree Celsius, you have to subtract from 273.15, subtract 50 from here. How, Vicha? If you see this here, this is degree Celsius. If you have to convert Kelvin to degree Celsius, what you will do? Your Kelvin minus 273.15 is equal to your degree Celsius here. That means the subtraction you have to do here. Right, so this is what we are doing here. So we'll just subtract it. This is going to be, wait a minute, this is going to be 50 minus 273.15. 50 Kelvin will be minus only, na? So let's see what is the value. It will be negative only, right? So 50 minus 273.15 minus 223.15 minus 223.15 degree Celsius it is, right? Degree Celsius, very low temperature, right? Now you have to convert it into degree Fahrenheit, right? So just put it here. This is degree Celsius. So this is minus 223.15, right? This is equals to 5 by 9. This is Fahrenheit minus 32. So what you will do, you will multiply it by 9 by 5 and this will be, Fahrenheit will be added here, right? And that is your Fahrenheit, degree Fahrenheit. That is going to be the answer here. Okay? Right, everybody? Right, you just need to solve this and you will get your answer here, right? Let us see what is the answer we are getting. Let us see. You also verify that. Okay. I'm just taking as 223 only. It is minus 369 something, right? It is going to be minus 369 something, right? Minus of 369 approximately, this will be the value. Okay, yes, everybody, don't worry, degree Fahrenheit, till now they have not asked about it, right? I am just giving you this example that what if they ask you, then you have to follow this process. Okay, what if they ask you, then this, your mind should be ready for this thing, right? Okay, now let us do the next thing, that is scientific notations. Now, scientific notation means that, for example, they have given you 0.0008. Now you have to convert it in this format. So it will be 8 multiplied by, this is 1, 2, 3, 4. So it will be 10 raised to power minus 4. For example, they have given you 8.314. So this you have to convert it like 8314 multiplied by 10 raised to power minus 3. Okay. So that is the thing that, now if you see this, this is not exactly making it very easy for us. Because it is, this n should be from 1 to 9, only then it is becoming easy for us. So this is not an easy value that we are giving. 8314 is still a bigger value, right? So this I have converted into a easy conversion here. For example, I have 800000. So I am converting it into 8 into 10 raised to power 5. So that is the easy thing that I have converted it into. Okay, everybody? Clear, everyone? Right, what we are doing here, right? We are converting a certain set of digits, right, into a notation that is n into 10 raised to power n, where this n can be from 1 to 9 and this small n can be any integer, minus or positive integer, anything can be there, right? Now, let's talk about the next thing. it is coming out to be minus 43358 Fahrenheit, then I think I might be wrong, right? So I'm not going to write the answer here. Do the calculation yourself, okay? Chal. Now, let us talk about this conversion here. Convert the following to scientific notation. So this is 3, 1, 2, 3, 4, 5. 5 zeros you have. So it will be 3 into 10 raised to power 5. This is the scientific notation that it will have. Now, if you have something like this, what will be the scientific notation? This is 1, 2, 3, 4, 5. So you can convert it into 832 into 10 raised to power minus 5. But we know that this thing should be in like 1 to 9, right? So what we will try to convert it into 8 point. 8 point. I want to convert it into 8 points. So I can also write it as, if I want to convert it into 8 points, so what I'll do? 0, 1, 2, 3. 3 dots are 3 decimals I have shifted. So answer will be 8.32 into 10 raised to power minus 3. Simple thing is, how many positions you shift on the right side, that is your minus of that number, right? I have shifted 3 times, 1, 2, 3, right? So it will be 8.32 into 10 raised to power minus 3. You can also write it like this, also like this, but in the numerical, right, they will not give you something like this. They will always give you something which is having only 1 decimal. Like after 1 digit, you will have the decimal. Right? These kind of values are given as the answers of physical chemistry questions. Okay? Right? Okay? I also get minus 433.4. Then I think minus 433.4 will be the correct answer only. Right? Okay? Chal. Now, let us do this. Convert the following to scientific notation. Now, let's convert this thing into the scientific notation. Let's convert this thing into the scientific notation. 8.8901. Do I need to write these 3 zeros here? After decimal, right? Only those zeros are valuable which are before any unit, before any proper digit. So before 1, this 0 has a value, but after this 0 does not have a value. So we just need to write it as 8.8901, and I'm shifting it to one place. I'm shifting it to one place, so it will become 8.901 into 10 raised to power minus 1. Okay, clear everyone? Clear everyone or not? Is that clear to everybody or not? Next is 3.2. This we don't have to convert. This is already in 3 point. Only after 1 digit you have the decimal. Already this is in the scientific notation. Already scientific notation. Now, why we are discussing these scientific notations? Because sometimes the answer that you will get will be something like this, right? But the options that will be given to you will be something like this. They can also give the option like 8.901 multiplied by 10 raised to power minus 2. And this is where students might get confused that what exactly I have to do. This is minus 2 plus 2. These are very small things where the students make mistakes and they end up losing their marks on these silly things, right? Now, let's do, now we will talk about addition and subtraction, okay? So write the answer in the scientific notation. So for example, in some calculation, you have something like this, right? Now, how you need to add this? For addition, always the power of the 10 should be same. This is 10 raised to power 3, this is 10 raised to power 5. So you have to make it same. So this will be 48.9 into 10 raised to power 3. Make this also 10 raised to power 3. How can you make it? This will be plus 2 into 10 raised to power 3, 2 into, this is 10 raised to power 2. Now, this is the common thing. Take this common out, right? This will be 8.9 plus 200 that you have to solve here, and that will be your answer here, right? So what I did, I made the 10 raised to the power, that should be your a normal value. That means that should be same. You want to make this also 10 raised per 5, you can make it. Multiply this by 10 raised per 2, divide this by 10 raised per 2. This will become 10 raised per 5 and this will be 10 raised per 2. You can also make it like 0.489 multiplied by 10 raised per 5 plus 2 into 10 raised per 5. Then you take 10 raised per 5 common, then add 2 plus 0.489. You will get the same answer. All you have to do is you have to make that 10 raised to power same. Okay? Yes, everybody. This video, ma'am, I'm gonna be very, very useful. Yes, yes, Kangana, this is going to be very, very useful to all of you. Right? You are really going to get benefited out of this. Right? Now, when you have subtraction, now we can't just directly do the subtraction. These kind of values you will see in your calculations. Now, being a NEET student, you get stuck here. Then what exactly to do? Because you have not gone through mathematics in so much detail. And even if you have gone through, some of you hate mathematics, right? So what you have to do here? Similarly, make the power of 10 as equal. So what I'll do? This is 10 raised per 6. I'll make this also 10 raised per 6. How? This I will, this is already 10 raised per 4. No. What I'll do here, I'll try to make which one common? 10 raised per minus 6. If I multiply this by 10 raised per minus 6 and divide this by 10 raised per minus 6, right, this 10 raised per minus 6 will become common and this will become 7.89 divided by 10 raised per minus 6, that will become multiplied by 10 raised per 6 minus 4 1.2, and this is whole is multiplied by 10 raised per minus 6. And after that you have to solve, right? Okay, so that is just a way to understand that what you have to do. Take a common value. This is 10 raised per, you have to make this also 10 raised per minus 6. So you have to multiply and divide this by 10 raised per minus 6. Multiplication, you have taken it as common. The division will come to the numerator side and it will become 10 raised per 6. And that is how you will have your answer here, right? Okay, ma'am, I have never done even a single question correctly. It's because of calculation. I don't know how to approach the question. What to do, please guide me. Siddiqui, firstly, focus on the unit conversions, right? Then practice, right? Whenever I am taking the sessions here, see that there is no one-liner answer to this, right? I can just give you some one line and that will be sorted. If you're not able to understand how to proceed to the numerical, do one thing. When I'm taking the lectures, right, join the live session and see how I proceed to the numerical, right? So understand that way. Firstly, try to understand how the teacher is thinking about the numerical. Try to understand the teacher, right, the way they are thinking about the question. Then do it the same way. Then replicate that thing, right? And you will have your own way of understanding. So when you have division, then it is simple. It is 2.34 divided by 3. 9.2, this is 10 raised per minus 5, this is 10 raised per minus 12, right? This you take here, this will become plus of 12, this will become minus 5, this will become 7. So this is going to be the answer. Divide it. And you know what? When you're dividing two things, the decimal has to be on the same position. So move the decimal here. When you're moving the decimal here, you have to multiply it by 10 raised per 1. See, whenever the decimal you are moving on the right side, decimal is moving on the right side, multiply it by 10 raised per minus something, whatever units you are moving it to. Whenever you are moving it to left side, multiply it by 10 raised per positive, right? So here we are moving it to only one decimal, that's why it is 10 raised per 1. Okay, how, ma'am? If you see this 3.92 is nothing but it is 10 raised per 1 is nothing but if you make it here, this will be 0 cancel. So this will become 39.2 only. Wait a minute. 39. Wait a minute. 39.2 multiplied by 10 divided by 10. This will move to here. Yes. Okay, yes, that I have written here. This is what you can use. Okay, understood everybody? Understood everybody? When you're moving the decimal to right, this will be 10 raised to power minus of that unit. When you're moving it towards left, this will be 10 raised to power positive of that thing. Right? Okay. Understood everyone? That was important thing that we have seen. Students do that kind of mistake. So it will be, when you do this, this will become 3.92 multiplied by 10. It will come to this side, it will become 10 raised to power minus 1 here, it will become 10 raised to power 6. And that is going to be your answer here. Yes, students, is that clear everyone? Is that clear everyone? Okay. See, simple is, let's say I have 789.224. I want to make it in the form of 7.89224, right? Then which, I should multiply it by which thing, right? So you are moving the decimal by 1 and 2. 2, so it will be multiplied by 10 raised to power 2, because you are moving it to the left side, so it will be positive here. So it will be multiplied by 10 raised to power plus 2. Now, if you have to do the reverse of this, let's say you have to make it into 78922.4. Then what you have to do? Now you are shifting the decimal to 1 and 2, but on the right side. So you'll multiply it by 10 raised to power minus 2. Okay? Understood? Ma'am, this feels easy? Easy? Right? This is what you have to do, right? Whenever you're shifting the decimals, because in the questions, like in NEET examinations also, they give the options like that only. You will have your answer as, let's say you're having answer as 1.89 multiplied by 10 raised to power minus 3. What kind of answer they will give you? 1.189 multiplied by this thing. Now, you don't know what is this thing. You get confused. You have to like solve this thoroughly, waste your time in that. We have 180 minutes for 180 questions, right? So what you have to do? We are shifting it to left side. Left side means it will be multiplied by, this is shifting to 1 unit, so just multiply it by 10. You will have your answer. Okay? Understood? Yes, everybody? Yes, everybody? Okay. Now, let's convert this. Let's use the next thing. Next is your pressure units, right? Next, students, we have pressure units. Let's try to do that. Till now, if you have any problem, then let me know in the chat box if any problem you have till now. Pressure units. Pressure units are, for example, let's say I am talking about, you have bar, you have atmospheric, you have pressure units are also mm of Hg, right? So many units you must have seen in physical chemistry, right? So that is the main catch. Conversion, which unit to use where, right? These things are important. So gases exert pressure due to collision of its molecules with the walls of the container. Now these pressure have 3 units: atmospheric, Pascal and bar. 3 units, that is atmospheric, Pascal and bar, right? So atmospheric pressure, then Pascal, and then bar, and you have mm of Hg also. Don't worry, we are going to talk about that also. The SI unit is the Pascal. Pascal is the SI unit, right? Now, most of the cases you will, it's not like you will always see this in Pascal. You will also see this in bar. You will also see this at pressure in atmospheric. You will also see this in mm of Hg. So that's why conversion becomes a very, very important case in case of pressure, right? One thing is, if you need to convert atmospheric to Pascal or bar to Pascal, that we should understand. So whenever I am not going to talk about kilopascal or kilopascal here, I am just going to give you the unit of Pascal. See, if you know Pascal, you can easily convert it into kilopascal, right? Smaller to larger, you will divide it by 10 raised to power 3, so it will become 10 raised to power minus 3. See, SLD, small to large, you will divide it by 10 raised per 3, that will become 10 raised per minus. So I'll do multiply by 10 raised per minus 3. It will be converted to kilopascal. You don't have to do anything for that, right? So that we are not going to focus on. Pascal to kilopascal, you can easily convert by multiplying with 10 raised per minus 3, right? But here you just remember that whenever you have atmospheric, multiplied with 101,325, that will be converted to Pascal. Okay? And remember that 1 atmospheric is greater than 1 bar. Okay? So whenever you have 1 atmospheric, you want to convert it into Pascal, you have to multiply it by 101,325. Right? So I'm going to write it here. Atmospheric to Pascal, multiply by this value, Pascal to atmospheric, divide by this value. Okay? Atmospheric to Pascal, you multiply it by 101,325, and Pascal to atmospheric, you divide with the same value. Right? Most you will see atmospheric to Pascal only. 1 bar to Pascal, you have to multiply it with 1, 2, 3, 4, 5, 10 raised per 5. So it will be 1 bar to Pascal multiplied by 10 raised per 5. Okay, 1 Pascal to bar, that will be divided by 10 raised per 5. Okay, that will be divided by 10 raised per 5. Okay, Center will teach this for students. They directly start lessons. Thank you so much, Punya. I know that that's why we are here, no? Because we know that what is the pain point of students, right? We understand that it's not that you guys are not able to understand the questions or this. We know that what is exactly lagging behind that teachers are not focusing on. That institutes just think that, okay, these are like NEET aspirants, so they must know this, right? So that is where teachers like should understand that students need to learn these basics also to understand the like chapters, right? Especially for NEET aspirants, right? It's easy for JEE aspirants, still it's easy, not very easy, but still it's easy. For NEET aspirants, it's even difficult, right? So atmospheric to Pascal, you have to multiply. Pascal to atmospheric, you have to divide. Bar to Pascal, multiply with 10 raised per 5. Pascal to bar, you have to divide with 10 raised per 10 raised per 5. Right? Remember this? Pascal to kilopascal, you can easily convert. Now, then we have the units. Now, understand one thing, students. Can you tell me what is the pressure formula? Pressure is equals to force by area. Pressure is equals to force by area. This you must have seen in physics. This is the formula of physics, that pressure is equals to force by area. Force is in newtons and area is in meters square. So that's why Pascal is nothing but it is Newton divided by Newton per meter square. This is the SI unit of Pascal. The CGS unit is, because Newton in CGS unit is dying. This you must have studied in 9th and 10th class, right? And the unit of area is centimeter in CGS, so that will be centimeter square. Now, why I am telling you this? Sometimes they don't ask you, they don't give you Pascal. They give that this is in bar, let's say 8 bar or whatever bar, right? And the answer is in Newton per meter square. Now, students have no idea how to convert this. Ma'am, we have not studied anywhere Newton per meter square. Ma'am, we are not like that. That's how, even after knowing full question, this is where you get stuck, right? So here what you should remember, that this is nothing but Pascal. And you know that how to convert bar to atmospheric, then atmospheric to Pascal, right? That you can easily do, right? Bar to Pascal, can you convert? Bar to Pascal is easily converted, ma'am. Just multiply by 10 raised per minus 10 raised per 5, right? Just multiply this by 10 raised per 5 and that will be your answer, right? Okay, this is what you have to remember in your exam, right? Okay, chalo. Now see this thing. Memories, like memorable, memorize for numerical. For numerical, what you have to memorize, this is very, very important, guys. 1 atmospheric, Understand this thing, because you will also see mm of Hg so many times in your entire physical chemistry. 1 atmospheric is nothing but 360 torr. It is also written as 360 mm of Hg. It is also written as 360 centimeter of Hg. Right? Okay. So centimeter still you will see very less. Mm of Hg and torr you will see like maximum. Right? 1 atmosphere is nothing but 360 torr, 360 mm of Hg, or 70, 360, I'm saying 760, I have to say, so sorry. 1 atmospheric is nothing but 760 torr, 760 mm of Hg, and 76 centimeter of Hg. Right? Okay. Okay, students. Now let us do the unit of volume. Right? Okay. Let's do the unit of volume. Now, what I taught you about volume? Volume is length into breadth into height. So it will be meters cube, centimeter cube, decimeter cube. Now I know that all of you know that, ma'am. We know, ma'am, there is milliliter, ma'am, there is liter. Ma'am, conversion is, ma'am, we have to multiply by 10 raised to 3. I know that. But do you know milliliter is meter cube or centimeter cube or decimeter cube? Liter is meter cube or centimeter cube or decimeter cube. This is where you get stuck. I know that this is where you're getting stuck, right? So that's why this thing is also important for you to know that milliliter, liter and meter cube are the 3 units, and meter cube are the SI unit here. Liter, and see this, 1 liter is nothing but 1 decimeter cube, right? And 1 milliliter is nothing but it is 1 centimeter cube. Right? This is nothing but 1 decimeter cube. This is nothing but 1 centimeter cube. It is also called cc. It is also written as cc, which means centimeter cube. Cc, centimeter cube. Right? So milliliter is also centimeter cube. Liter is decimeter cube, and meter cube does not have liter or milliliter conversions. Right? That is simply meter cube. Right? Okay. Now, see this thing here, right? See this thing here. Meter cube is largest, then you have this, then you have this. Right? Now, bacha, see this thing here. How to do the conversions. Right? Conversions becomes a very, very important part here. Right? Now, if you see, this is liter, this is milliliter, right? Liter to milliliter, if you see, the conversion will be, if you talk about this milli is 10 raised to 3, smaller to larger will be multiplied or divided. That will be divided by 10 raised to 3. So, whenever you do convert milliliter to liter, it is divided by, let's say you have 10 milliliter. You have to convert it into liter. This will be 10 multiplied by 10 raised to minus 3 liter. Because you have to divide it by 10 raised to 3. So that will be multiplied by 10 raised to minus 3. And that's how you will get your answer here. Right? Let's do the other part as well. But for that, you should understand one thing. That 1 meter cube is equals to 10 raised to 3 decimeter cube. Decimeter is nothing but it is liter. So that's why we say that 1 meter cube is 10 raised to 3 liter. Right? Now, beta, see, that means the difference is 3 only. Here also, right, I am just writing it here. In a simpler version, I am writing. This is also multiplied or divided by 10 raised to 3. This conversion is also multiplied or divided by 10 raised to 3. When you are converting from smaller to larger, it is divided by 10 raised to 3. When you are converting, let's say I want to convert meter cube to liter. I have 30 meter cube. I want to convert it into liter. So it is 10 raised to 3. So what I'll do? This is larger to smaller. Larger to smaller, I'll multiply. So I'll do 30 into 10 raised to 3 liter. Okay? Yes, everyone. Is that clear to everybody or not? Volume units, is that clear, students? If that is clear, then let me know in the chat box if that is clearly, like fully clear to everybody here. right? Okay, so that I can start with the next thing here, right? See, 10, see 1 decimeter cube is liter only, so 10 decimeter cube is 10 liter only. So this is where they confuse you. Instead of giving milliliter, they will give you decimeter. Instead of giving milliliter, they will give you centimeter cube. They will give you cc, that is milliliter only. Instead of giving liters, they will give you decimeter cube. That's where you will get confused in the exam, right? So let's do this thing, that is average human has 5.2 liter blood, volume of blood in not milli, in meter cube. So from liter to meter cube, that is from smaller to larger, you have to divide. What I told you, SLD, D, divide. So divided by what? 5.2 divided by 10 raised per 3. So it will be multiplied by this. So answer will be 5.2 into 10 raised per minus 3. Answer will be B is the correct answer here. Okay, B is going to be the correct answer. We are proceeding towards the end of the lecture, guys. Almost 2-3 units only we are left with, right? Let's see this here. Let's see this. That is energy units. Now, if you see the energy units, right? Energy, like thermodynamics, you have maximum, it is used in thermodynamics, then it is used in electrochemistry, some formulas, in chemical kinetics also some formula it is used, in structure of atom it is used. So energy conversions are very important, like joule, kilojoule, electron volt, right? These are the conversions that are important. So energy, firstly, it is in joules, it is in electron volts, it is in calorie, all these are the units. Okay, so if you see this, first is what important for you, that joule is nothing but it is Newton meter. Why, ma'am? Because energy is nothing but, energy is nothing. Can you tell me the formula of energy? That is nothing but force into displacement. This you must have studied in your physics. See, I have not studied physics from the past, I don't know how many years, but I still remember these formulas, okay? Energy is equals to force into displacement. So force is Newton and displacement is meter, so answer will be Newton meter. That is 1 joule, that is the SI unit. That is your, you can say, SI unit. This conversion is very, very important for you. If you have to convert 1 electron volt to joule, multiplied by 1.62 into 10 raised per minus 19. Now, ma'am, if I have to convert 1 joule to electron volt, divide it with 1.602 into 10 raised per minus 19. That is nothing but, that is 6.24 into 10 raised per 18. Right? This value already is solved. Right? So, this is the most important conversion of converting joule to electron volt or electron volt to joule. Very, very important conversion. Now, this is not very important, but still calorie to joule, like till now, very rarely they will ask you, but still you can know this. 1 calorie is 4.1 joule, right? If you have to convert calorie to joule, multiply it by 4.1. If you have to divide it, if you have to convert joule to calorie, divide it by 4.1. Right? So that is going to be the answer. Okay? Right, everyone? Okay. Ma'am, please give the PDF download on this lecture in the comment section. Yes, yes, Isubia, don't worry about that. Right? That will be provided in the description box. It is not provided very instantly, like by tomorrow morning or today by night, you can see that it will be uploaded, right? Maximum tomorrow morning, right? On the comment section and as well in the description box. That will be uploaded, right? Don't worry about that, right? Okay, yes? Okay, great. Now, let's talk about the constants. Till now, unit conversions we have done. Now, let's talk about the constants, right? First thing is, I'm talking about gas constant. Now, this is actually a very, very confusing thing for students, that ma'am, where I have to use, you all must be very well aware of that it has 0.0821 value, it has 8.314 value, it has 1.98, or you can say 2 is the value. These are the three values of gas constant. But ma'am, gas constant, which value I have to use where? Right, so see this. Whenever in the formula, right, you have volume, you have pressure in atmospheric, right? You have volume in liters or milliliters, anywhere also it will work. But volume, if you don't have volume in liter, you have to convert the volume into liter. I have told you how to convert the volume into liter, right? Now, if you have volume in liter and pressure in atmospheric, then you will use the formula as 0.0821, right? That is the formula. That is also nothing but you can just write it in fraction as 1 by 12. You solve in calculator 1 by 12, that will be nothing but 0.0821 only, right? Now, if pressure, if they are not talking about any volume, right? Or volume is not there only, right? And they are talking about energies. Mostly you will see energies only. If they are talking about energies, then you will use this formula. But remember that energy has to be converted into joules for this. You have to convert the energy first into joules, only then you can put this formula. If energy is in kilojoule, you put the value of R in joule, then difference, then the answer definitely will vary, right? These are the things that we don't actually see. Where, ma'am, I had done the paper, ma'am, I have practiced it so many times, I'm still not able to identify why my mock test marks are not good, because you're not giving value to these things. Energy is in joules, then this also will be in joules. If this is in kilojoule, you have to convert this into joule. Okay, if this is in electron volt, you have to convert it into joules, right? Or pressure is in Pascal. Very rarely you will see in pressure you are applying this, right? In your syllabus, mostly in energy in joules you are applying this value, right? If it is given energy in calories, then you have to apply this 1.98 as the value of gas constant, that is approximately taken as 2. And this 8.314 is also taken as 25 by 3 in fraction, so that your calculations are made easy, right? Okay. Today I have only 2 sums, right? From tomorrow I'll give you 3 questions, okay? From tomorrow I'll start giving you 3. If you all do, see, one promise I do, if you all the students who are present here, they are doing their homework, right? That I can see in the chat box, right? You are active in the chat box, then I will do more hard work for you. Then I also prepare DPPs for you, right? But I need to see that you are also putting in efforts, right? But just me putting the efforts will not work, right? So you also have to put in the efforts. If I can see consistently you guys are doing homework for 1 week, right? You're also there in the class, live sessions, you're also interacting in the class, you're participating in the class, I'll start providing with the DPPs also. But everything comes at a cost, and this cost is your efforts, your dedication towards the lecture that I want to see, right? Okay. Now students, let's talk about Rydberg constant, right? Rydberg constant. Now if you see this, in Rydberg constant, right, the value Rydberg constant, there is one Rydberg equation that you have, right? That is nothing but 1 by lambda is equals to RHZ, right? 1 by RHZ square, RHZ. Z, if you take 1, I'll take it as 1. N1 square by N2 square, right? Now, see, if they're asking the value of lambda, this, don't worry if you don't know this till now, we will use this formula. If you're asking the value of lambda, then you have to see the value of it in RH, right? So, if you're asking the value of lambda, then you should also know what is the value of 1 by RH. Okay? If you're asking the value of wave number, then value of RH will work, right? So, let's talk about the value of 1 by RH. 1 by RH is nothing but 912 angstrom, and here your value of lambda wavelength that you will calculate will be in angstrom, not in centimeter or meter. And then you have to convert angstrom to meter, nanometer, picometer, centimeter, whatever they have asked you. right? But the value of simple RH you can see here, that is this in per meter. You can remember this value, that is 1. You can just simply write 1.097 10 raised to power 7 per meter, or you can also write it as 10971. Also you can remember this in centimeter. That's totally your choice, right? Okay, but this is important that this value in angstrom, 1 by RH value is 912 angstrom. Okay. Okay, students. Thank you so much, ma'am. Bless you always with good health. Thank you so much, ma'am, for your effort in teaching, ma'am. I will always be active, ma'am. Promise. Thank you so much, Sibla. Uh, Eusebia. I am so sorry if I am pronouncing your name incorrectly. Do correct me in the chat box. Right? Okay. So very happy to know that you guys are excited. You are having fun in the class. You are learning something from the class. I'm very happy from that. So, students, these are the constants. Constants, now I am just giving you the chart here. It's not like now only you have to remember. This depends. If you're someone who is in class 11th and you are watching this, don't remember this. You will see all of this in your class. You can even ignore this Rydberg constant for now, right? Because I'll teach you this in the class only. But if you're in class 12th, right, then you can remember these things because this you have done in your class 11th, right? So this will be a good revision, right? And if you're a dropper, surely you should go through these constant and remember these constant within 1 week, right? Because being a dropper, you should remember each and every constant. You don't have time for that. You have to practice a lot, right? So speed of light 3 to 10 is per 8 meter per second, gravitational constant 9.81 meter per second, atmospheric, AMU, atomic mass unit. This we will study in some basic concepts of chemistry, right? Mass of electron, mass of proton, mass of neutron, Rydberg constant, Bohr radius you will study in structure of atom, charge on electron you will study in structure of atom. This you will study in some basic concepts of chemistry. Planck's constant also you will study in structure of atom, right? Faraday constant is you will study in like most of the things, but in electrochemistry it has a very high use, right? Faraday is nothing but 965, approximately 96500. You can take the value, right? Boltzmann constant from your today's syllabus, what we have, it is not useful for you, right? So you can neglect this also, right? Okay. Now those chapters are not in your syllabus at this point, so you can neglect this also, right? So that is your full list of units, right? Physical constants. And here, student, this is your homework. Everybody take the screenshot of the homework page. The SI unit of Rydberg constant in context of wavelength and energy respectively is what, right? So you have to tell the SI unit of Rydberg constant in context of wavelength and energy, right? Then what is the SI unit of volume? This you have to answer. Take the screenshot. I want to see that how many of you actually do your homework. I'm not going to insist you, right? I just want to see how many of you are concerned enough to do your homework, right? If the teacher is putting in efforts for you, right? Let's see that. How much dedicated you are for your NEET preparation, that I have to see from your daily homework, right? Okay. So that's it, students. And one very important thing, you know that we have very good results here. That's why on 21st of June, we are conducting basically we are congratulating, and this is a VAL function that we are VAL celebration basically that we are doing here, in which we want to celebrate the results. We want to celebrate every student of Vedantu who have scored really good marks, and to motivate all the aspiring candidates out there who want to be like them, who want to be the shining stars, right? So this is for all of you, right? On 21st of June we are doing that, and that will be live on the channel. And students, you can see that DNA batch, right, that is going on right now, where I am also teaching, right? You will see, just now one student said that, ma'am, nobody teaches all these things in the batch, but in our batches, right, we teach things in so much detail, right? You can see the kind of mindset we have, that we have to teach you everything that is painful, that is a pain point to you, right? So we take the doubt sessions in the class, right? We take practice sessions, we take review DPPs in the class, modules are provided to you, mock tests are provided to you, right? Test series are provided to you, all the things are there, right? And the batch, if you see, is just at 3,999. That is the price of prime batch. Combo is where we are also going to provide you these QR cards, right? These QR cards we are going to provide you. That combo is for 4,999. And if you want to purchase combo plus, that means you need to have these QR cards for your short revision. Plus you want to have the test series delivered at home. In this case also you will get the test series but not delivered at your home, right? Here you will have the, Tattva books delivered at your home. My bad. Tattva books that are delivered at your home. In this also you will get the Tattva modules, but that will be in the soft version. This will be in the hard copy version, right? And if you're someone who is like offline centers, guys, that are already open for all the students of NEET 2027, right? Offline and repeater batches also there where IVSAT programs are going on. Everything is in the description. And students, if you are like looking for a good offline center, then you can see our Vedantu centers. You can just visit the nearby Vedantu center. You can just tell that I am a student of Vedantu NEET English, Diksha Ma'am, and I need this counseling, I need this guidance. Please kindly tell me what is going to be this. Now, you are a repeater, you are in class 11th, you are in class 12, this is applicable to all the students. But if you are looking that, ma'am, there is no Vedantu center that is nearby by my house, right? First thing is I would ask you to check it out, right? If it is not there, still you want an experience of offline when you're sitting in your home only, right? That is our pro batches we have for you, that is in English. So these are 300 plus live classes you will have, 100 plus biology, chemistry and physics. All the lectures will be there, right? Now in the pro batches, ma'am, but what is the difference, right? In the pro batches, what exactly we will have? See, in the pro batches, just like you all are sitting there, right? It's just that your cameras will be on in the pro batches, right? And even I can see you, right? You are not muted, right? You can talk to me any point in between. You can say that, ma'am, I didn't understood, please repeat it again, right? And you have any query, you can ask in the not in the chat box, but like you are sitting in the class, that way only. One more thing is you will have your personalized mentor who is going to see that whether you are studying, what is your growth, right? What are the more improvements you need to do, all of that, right? That is your personal mentor will be provided to you, right? And you can ask your doubt session 24/7 to them, right? That is all completely provided to you in the pro batch. And in the pro batch, students, what is the price? The price is at 72,72963, right? That is pro, and pro plus is at 84942, right? Okay, so all the details are in the description. If you have still any query, you can you can visit your nearby Vedantu center, you can call on the Vedantu center, anything you can do. You can also ask me in the comment section if you have any query regarding prime batch or pro batch or offline center, right? So guys, that's it for today. This is our Telegram channel. You can just scan the code and you can just subscribe to the Telegram channel, because live classes, everything, all the details of the lecture are there in the Telegram channel, right? And students, I want you guys to do the homework in the comment section. Okay, let us see how many of you do the homework and also like the session, right? So many beautiful comments you have given in the chat box. I want you guys to also write all the comments in the comment section, right? And subscribe to this channel, share this channel, like the video, right? That will appreciate me also. Even I will get that, okay, these students like the content that I am giving, right? So that pushes me to do more hard work for you guys, right? Okay, yes. Okay then, student. Okay then, students. Bye bye. Take care. See you all in the next class. Bye bye.